Okay, so it's similar to what we do in Python. So what we do in Python, we had data types like integer, string, float. Now, if you talk from data science perspective or data analytics perspective or analysis of data perspective in real life, what are different types of data? Okay, so you will have something called as quantitative data, and you have qualitative data. What is quantitative data and qualitative data? By definition, what do you understand?
Quantitative means how much data, sir. Qualitative means
Quantitative, like we can count it or measure the like numerical values of that data.
Okay, so see, so if I ask you, okay, what are the benefits of um, using or using data science, for example? Okay, what are the benefits of using data science algorithms for a retailer, right? So you have
Mm.
a retailer, and what is the benefit of using data science algorithm? Why should they use data science algorithm? So you can tell me that it will make their life easy. It will take less time. It will okay. Now, when you say it will take less time, it will be more correct. It will. So you are
business
giving
applications.
correct. So you are telling me qualitative stuff. Okay. So these are something that you cannot measure. Okay. If I tell you, okay, it will make things easy. Okay. It will make things easy. How do you measure things easy? Okay, so
We
before
can
how much time you're taking, now how much time you're taking. So it will reduce the time by 30%. When you say it will reduce the time by 30%, that is the
30%
number you're talking about.
quantitative.
Qualitative data you cannot measure.
Yeah.
Okay, okay. If I ask you, okay, okay, rate my session. Okay, on 1 to 5, rate how much how much points rating you'll give to my session. Now, this is 1 to 5 when I say it is qualitative,
Quantitative.
right? Now, you might give 2, somebody might give 4. Now, same presentation, okay, one of you might give 2, other might give 4, right? Because there is no way to judge it, right? You felt it is 2, you felt it is 4, correct? Now, if you say that, if you can measure the quality, then the value would be same, right? Like if I tell you what is 5 plus 3, both of you will say 8, isn't it? So qualitative data is one where you can easily measure. And when you are measuring it, okay, the the difference in the output is not much, right? But when we talk about qualitative, right? For example, true and false is an example of quantitative, right? Because when you evaluate true or false, both of you will be able to give same marks. Now,
Yeah.
okay, now let's say um, if I write an essay, right? if if I write an essay example, right? Now in essay, of course, one of you can give 2 out of 10, one of you can give me 5 out of 10, because that is difficult to measure. So qualitative data are difficult to measure, right? Rating, when I say rating, right, when you rate somebody, there is no logic, oh, this is what I feel, right? Now if I ask you whether weather is hot or cold, right, you can say it is hot and one of you can say it is cold, right? Now if you get somebody from Alaska, this is like what I mean, this summer is like hot, very hot. If you get somebody from Sahara Desert, they'll say, oh, this is nice weather. Yes or no? That is qualitative. Okay, same weather, they're sitting next to each other in a room. One of you will say it's very hot. One of you say it is nice weather. Okay, now if but if you ask what is the temperature, both will say same temperature, isn't it?
Yes, they will say same.
Same temperature, whatever, 36 degree, 35 degree, 38 degree, 40 degree, whatever we have. Because you can measure the temperature. You can measure the temperature, but you cannot measure how you feel. Feeling is totally up to you. So that is what qualitative data is. Okay. So quantitative data is numeric. Agreed? And qualitative data can be text, can be categorical, what we just said. Categorical means, okay, the rating 1 to 5. So it's a category. Okay. So quantitative are your numeric data. Okay. Now numeric data can be like cost, price, temperature, pressure. Okay. These are your right. Okay. Now qualitative. Okay. So apart from qualitative, you can have text data. Okay. Now text data is when we do Twitter analysis, Facebook post analysis. Okay. You take entire text and you analyze. That is even different than qualitative. Qualitative, we just said it can be your categorical data. Categorical data means data which has category. Category. Okay. So here also, okay, we'll talk about categorical first. Categorical data can be again two types. It can be nominal and ordinal. What is nominal? What is ordinal? Nominal is for namesake, kind of, you can say. Nominal, it is namesake, like male, female. Okay. Now, male, female, you cannot say which is better. Male is better, female is better. No. I mean, there is no order. You can say male, female, or you can say female, male. Makes same. Okay. It doesn't make any difference. You can say regions, right? North, south, east, west. Okay. Now, there is no particular order. You can say east, west, south, west. Anything you can say, right? South, north, west, east, anything you can say. Where order is not important. Nominal data is where there is no order in the values. There is no order in the values. I can say male comma female. I can say female comma male. I can say south comma north. I can say north comma south. Right? Now, ordinal is where there is an order. Okay, so for example, course rating, right? I'll ask you, rate me from 1, 2, 3, 4, 5. Now here you see, I have to say 1 to 5 or 5 to 1. I cannot say 2, 3, 1, 5, 4. Order is important here, right? Good, bad, right? It could be good, average, bad. Rather, it is good, average, bad, or bad, average, good. Correct? It cannot be average first and bad next and good last. Because when you say something, there is a meaning. There is a meaning to the order. Order has a meaning. They are called ordinal data. So when we talk about, okay, in SQL, we discussed about, again, two types of data. What are those two types of data? Structured and unstructured data. Structured data is your quantitative and qualitative. Okay. Text data is unstructured data. Text. Okay. It can be voice, audio, video. These are all your unstructured data. Okay. So if when you are doing data analysis, okay, you have to convert these unstructured data into structured format. We'll see how to do it later. But first our focus is to understand what is quantitative and qualitative, and we will do with this data only analysis. Okay. Now numeric data can also be two types. Okay. So numeric data can be like what we say, you have like ratio, okay, and what is that called? Interval data. Okay. Now here you can have continuous or discrete. Okay. Continuous spelling is wrong. Yeah. Continuous can be your ratio, or what did I just say? Interval data. Okay. So what is discrete data? Okay. Discrete data is data which will have okay, you can assume it to be like a very big categorical data. Okay. So if I ask you how many marks did you get, right? Now how many marks did I get? If I ask you how many marks will be 35, 35.5, 55, 85, 95. You cannot say 98.9999999. Okay. When you have anything possible, and infinite kind of possibilities, when you have infinite kind of possibilities, we say continuous data. Infinite kind of possibilities. Okay. Okay. Give me a number, and there is no condition to it. You can say 55.99. Okay. Now, the classic question that I ask is, what is the probability of, okay, someone, when you pick someone, what is the probability of, okay, probability of getting, what do we say, 70 kg. If you
Getting
pick
rain
someone,
today.
sorry.
Sorry, you continue.
Yeah. So I was saying that if I pick someone from your city, what is the probability of that person's weight to be 70 kg? The answer is 0. Nobody will be exact 70 kg, right? Because if you take a scale where there is no decimal point, you will have 70 kg. If you take a scale which will have one decimal point, it will tell you 70.1. If you take scale which has 20 decimal points, okay, it will tell you 70.125922652, right? So values which can take infinite values, they're called continuous values. Example I gave you, isn't it? Example is weight. Okay. Temperature. Okay. If your temperature, if your scale, okay, etc. If your temperature scale, okay, does not have decimal point, it'll tell you 23 degrees Celsius or 33 degrees Celsius or 38 degrees Celsius, right? But if you have one decimal point, you can see my screen. Can you see 35 degrees Celsius at the bottom? No, probably you won't be able to see. Do you see?
No.
No, okay. I think when I share full screen only, you'll be able to see. Okay, so my laptop shows temperature as 35 degrees Celsius. Okay, there is no decimal point. If there was one decimal point, it would have shown 35.6 34.3 or 34.9 degrees Celsius, isn't it? Okay. These are called continuous values. Okay. Continuous values means it can take continuous, okay, any value possible. Now, if I ask you, how many cars did Tata manufacture last year? How many cars? Now, it can be a very big number, 10,000, 50,000, okay, 5 lakhs, 20 lakhs. But still, it is not continuous. You cannot say 20.9999 cars. It is discrete. So many times you come across discrete and continuous. You have to make distinctions in your mind whether that number is discrete or continuous. How many cake did you order? 1, 2, 3. How many people came to your party? 50, 40, 100, 500, 551. How many books have you read last year? It could be 5, 55, 95, right? So these are your discrete values. It cannot take any value depending upon scale. So discrete does not have any type. But when you talk about continuous values, since it is difficult to represent continuous values, why, if I ask you what is my weight, okay, if you ask the robot what is robot's weight, robot will keep on going forever, right? 45.9252628910 whatever, right? That kgs, it'll go on till you'll say, okay, give me only till 2 decimal places, give me only till 3 decimal places. That is called interval data. Interval is you're creating an interval. Okay, give me at 1 decimal place only, give me 2 decimal place only, give me 0 decimal place. Okay, give me, so when you say 0 decimal place, basically you are saying interval of 1. Interval of 1 means 1, 2, 3, 4, 5. You are making continuous as a discrete value. So though it will show you 45 or 75 or 85, but you know that it is not exactly 85. It is not exactly 75. It's not exactly 45. Are you following me what I'm saying? Okay. You write 85 because there is no decimal place. Now, for example, okay, if you have to fill up a form where you have to mention height and weight, if they don't mention decimal place, you will give weight in non-decimal values. If they say dot one more decimal place, then you have to give in 1 decimal place, isn't it? Depending upon what interval they give you, you will write the data in that format. Are you getting it?
Yeah.
Abhiram?
Sir,
Okay. Now, second type is called ratio. Ratio is out of, 1/3, 1/5. Okay, this is called ratio. Okay, these are your continuous data, which which you have to use either ratio or interval to talk about. You cannot use exact value, right? And discrete is where you can use exact value. You can use exact value. Okay, your average can be continuous, but your marks in subject is discrete. Number of people in your class is discrete. Okay, education qualification. Now, education qualification is qualitative. You can say that, okay, less than 10th or intermediate or graduation, post-graduation, above post-graduation. You're creating these groups to measure people's education qualification. That is an example of categorical data. And will that be nominal or ordinal?
Ordinal, I guess.
Ordinal, yes, because it
Yes.
has to be in one specific order. You cannot
Yeah.
use your order, your own order. You cannot say first graduation, second post graduation, then 10th pass, right? There is an
Yeah.
order in which you have to give the values,
The values according.
right?
Yeah.
So this is what you have to do. Make sense?
Yes.
Okay. Okay. So now these are your data set. Now, how do we handle this data in analysis? That's what we have to do. So when you talk about representing these data on, let's say, on graph, right? And to represent this data on graph. Okay. So we'll talk about just qualitative data for now. Okay, these things we'll do it later. We'll do quantitative and qualitative. Let's start with quantitative data. Okay, so let's say, okay, let's take these data only. Weight. Now these are called univariate. Univariate means one variable. Then you have bivariate or multivariate. Bivariate means two, multi means more than one. So let's talk about bivariate, univariate, multivariate. Multivariate. Okay, univariate is where you have only one data. Weight, okay, marks, okay, gender, regions. What else we have? Course rating, weight, marks, temperature. Okay, now tell me, I want to represent weight, okay, in visualization. What all graph can I use? Let's say sales also.
What graph?
Which all graph? How do you represent weight? Okay, so you have, okay, you have 100 people and you have weight of 100 people with you. Okay, how do you represent the weight of 100 people? How will you represent this?
I can use scattered plot.
Scatter plot. How do you use scatter plot?
X-axis and Y-axis. So
I'm
on
talking about
Y.
univariate, one variable. What is x-axis? What is y-axis here? When you are
Sorry.
measuring weight, when you talk about weight, what will be x-axis? What will be y-axis?
Sir, histogram.
Two variable histogram.
Yes, the scatter plot is for two
Two
variable.
variables.
Okay. Yes, for weight you can use histogram. How will you use histogram? You have 100 people, right? How will you use that? How will you, right? Your answer is right, histogram. But how will you use histogram?
Like considering weights as a y-axis and like persons in the x-axis.
Histogram, sorry, weight as what?
Y-axis.
Y-axis. When you see, whenever you draw a plot, it will have two axes.
Yes, sir.
Whenever you draw a plot, it will have two axes, isn't it? So
Yes,
which will be y-axis? What will be x-axis?
Y-axis will be weight.
1 second, yeah. Yeah, go ahead, Abhiram.
Y-axis will be weight, sir.
Y-axis will be weight, okay.
Yeah. And the person's name or some identity will be the x-axis.
In histogram, how will you create identity, name? If you are plotting, see, when you are taking identity or name, you will have 100 data. Okay. Now 100 data, how can you plot? Let's say you have, let's say our three weight you have. Okay. Mona Lisa is 50, you are 60, I am 70. How will you plot?
Let's take from the 50 to like a 0 to 100 is the weight range, sir, in the y-axis. And our three names will be in the x-axis, like three names will be in the x-axis. And there will be a if the way if the line will be starting from the 0, if my name will come, it will be in the 60, and if your name will come, it will be some peak or down.
Okay.
I guess we have to find.
Open a paint. I'm sharing the screen to you. Just roughly you demonstrate.
Yes, sir.
Okay. I'm stop sharing. I'm giving access to you. Okay.
I'll open it.
Open. Yeah. And show me using paint. How will you do it?
Is it visible, sir?
So we
Paint
have to
Yes.
find the
Wait.
frequency.
Let him do it.
like
Yes.
like it takes 0 to 100, sir.
Mm-hmm.
In between some values like uh difference will be 10. And person
Okay.
1, person 2, there are 3 persons.
Okay.
For suppose person 1 is me, sir, person 2 is you, and person 3, sir. And the graph starts will like this. And my weight is belongs to, for suppose it's a 60 here, and your weight is 50 means it will decrease here. This is the one point will be, sir, like this.
Okay.
And her weight belongs to like 40 or some 70. If the 40, the graph will decrease, or if it is more, it will increase. Like the coach of we can see, no, sir, our rating.
See, rating is different. Weight is different. Why rating is different and weight is different? Okay. First of all, this is not histogram. Okay.
Sir,
Yeah. Go ahead.
so
Uh,
like from so like we have 100 people. So first we have to find the frequency, like 40 to 50. How many people like laying on that interval?
Okay. And
After
then what?
finding that, so at y-axis we are putting the frequency 1 to 100, and on x-axis we are putting weight interval, and then we will able to create the histogram that okay, 40 to
You
50
want to
class
share your screen
interval we
and
have.
show us? Okay. Can you
uh,
stop sharing? Yeah. Melissa, just share your screen and
oh,
discuss.
1 minute.
Yeah.
So can we do it in the clustering, like after doing the clusters or classes?
Clustering for classes. What is
So
class here?
like a similar type of weights or between one range. Like if 10 persons are between the 50 to 60, they will be on
Exactly. That's what we have to do. I think that's what she's also saying. We'll see what she's
Yes.
saying.
Oof, why it's not?
extend the paint. Yeah, the box.
I didn't use that. This one.
Yeah.
Okay. It's not like मैं create नहीं कर सकती, but like, did you understand what I'm trying to say? It's like
I
40 to
understood, but I
50.
want to make sure that what I understood is what you are saying. Okay. No worries. Give me, stop
This
sharing.
kind of graph,
Give me. Yeah.
this kind of I'm saying either यहाँ
Yeah.
पे we
This
have
kind of, but how do you,
frequency,
yeah, but how do you get? Okay.
here
Let me do it. Let me
frequency
do it.
are
Let me
there,
do
and
it. Let me do it. Okay. I'm stopping your screen share. Okay.
yeah.
Okay. Correct. So, so something like that, and I'll show you. Okay. So first thing, what you showed, Aviram, was it's a line graph. Okay.
Yeah.
Now the problem here with this data set, okay, you can draw a line graph also, but the line graph is not going to tell you anything. Point number one. Why? Because in line graph, okay, what is important is also the values that you put on x-axis, right? Now, if I tell you sales, for example, sales you have, right? Now, sales will always have date associated. Sales, even though you say it is a univariate, because you're talking about sales, but underlying sale will have date, Jan to December, okay, 2010 to 2022. So when you plot a line graph, you know that right side comes after left side, obviously. Okay, so when you see a line graph, okay, let's start with sales. Since you have spoken about the line graph, we'll start with sales only first. Then we'll go to weight. So let me show you paint, okay?
Sir,
Wait, yeah, tell me.
in this way also we can take like if we consider weight.
No, wait. Let's finish what we're talking, okay? Then we'll come back to it, okay? Let me finish and then you tell me, okay? Now, so when we talk about sales, the last item that we took, so now in sales, if I draw a line graph, like what Aviram had drawn, like this, okay, or like this, or, something like this. What does this indicate? This indicates that, okay, the black one says that sales over last 10 years, 15 years, 20 years, okay, or 20 months, 10 months, 12 months is decreasing, right? There's a decreasing trend. Here you will
Yeah.
say the light blue that, sales over the
Increasing trend.
years, over the months, over the weeks, over the days is increasing. Blue, you will say that, company had a good time, but then something happened, it went drastically down, almost bankrupt, but again, now it is rising up and doing well, right? So when you draw a line graph, okay, obviously on y-axis, what you said, the numbers will be there. Like in this case, it could be 0 to 1. Here it could be 1 crore to 1,000 crore, or 1 crore to 500 crore, 1 crore to 10,000 crores, whatever. But when you're drawing the x-axis, there is a order that is associated with x-axis. If there is no order associated with the x-axis, you cannot draw a line graph. Now, in our 3 case, if you're taking 3, weight, should you put my weight first, your weight first, or somebody else weight first? Okay, because the graph look will change. If you put increasing order or decreasing order, or if you put, the things will change, right? You can talk in some terms, okay? You can talk in terms of height. You can, you talk about people with height versus weight, So there again, 2 number will come into your mind, which will talk about the value on y-axis and the order in which you put on x-axis. So sales, it is a 1 number, it is one univariate, but when you're plotting, automatically the date will come. Okay, that's why we still consider sales as, because sales cannot exist without date, right? So when I say human being, it means we have 2 hands, 2 legs. I don't have to say human being with 2 hands, correct? Human being with 3 legs, if it is there, only then you'll mention. Otherwise, when it's a human being, it means it has 2 hands, 2 legs. When I talk about sales, it means it is, it has a date associated. Okay, we call them as time series data. Time series data will always have time. You can talk about daily sale, hourly sale, monthly sale, quarterly sale, weekly sale, annual sales, whatever, right? So, okay, sales will be, because, if you have to put data here from 2010 to 2022, this is 2010 and this is 2022. And it will be like 10, 11, 12, 13, 14, so on to 2022. That's what it means. Okay, so what you just said can be applied on sale data. Now, what you both were saying towards the end is this. Now, when you talk about data from 1 to 100, now plotting 100 data, okay, first of all, is very difficult. Second thing is, you don't know how to plot. How will you plot it? So what we do, we look at the lowest and the highest value. We create what is called as histogram, correct? To create histogram, first you have to create what is called as frequency table. Okay, so frequency table, okay, we have to create frequency table first, and the frequency table can be plotted as a histogram. So what is frequency table? Okay, so let's say you have minimum weight as 30 and maximum weight as 120. Okay, so you will roughly take 10 parts. 30
Yes.
to 120 will be about 90 kg difference, right? That means we'll take about 9 kg or 10 kg, okay? So 9 kg, 7 kg, 7.5 kg, 6 kg, doesn't make sense. If it is 6, 6.5, 7, you can make a group of 5 also, 30 to 35, 35 to 40, so on. Okay, in this case, maybe we'll make group of 10, 30 to 40, 40 to 50, okay? So you will say 30 to 40, okay? 40 to 50, 50 to 60, 60 to 70. Now this is called frequency table. You are declaring a frequency. This is called frequency. Okay. Frequency means number, how many times it is occurring. How many times it is occurring. Okay. So now how many people have weights between 30 to 40 kg? Okay. Let's say 5 people. 40 to 50 kg, 15 people. 50 to 60 kg, 20 people. 60 to 70 kg, 25 people. 70 to 80 kg, 30 people. 80 to 90, 90 to 100, 100 to 125 people. Okay. Now you take your, okay. Okay. So histogram is a bar graph representing frequency table. Histogram is bar graph representing frequency table. So now you will say here 0 to or 32, right? Minimum is 30, isn't it? Okay. So, but 30 to 90 is not done here. Okay. On y-axis, we plot frequency, not the weight. Weight has no significance here. I'll tell you when it has significance. Okay. Frequency. So maximum is 30, minimum is 5. That means you can say 0 to 30. Okay. You can draw at 2, 4, 6, 8, or 5, 10, whatever, right? Let's draw at 2, 2, 4, 6, 8, 10, etc. Now 30 to 40 is 5. So this is 30, this is 40. 30 to 40 is 5. So somewhere here. Then 40 to 50 is 15. 15 is, let's say, here. Okay. So you will say here. Okay. 20. So 20 you will say here. Then 25 will be somewhere here. 30 somewhere here. Let's say 15 again. This is called frequency table, and this is called your histogram. So now if I, just to show you, you can put different colors to indicate these different bars. Okay, it's because we have not joined this. Okay, that's why it's spilled out. Okay, this is your histogram. Weight will be represented like this. If you have only single variable weight, you'll create a histogram to show. Now people know, oh, okay, most of the weight lies between 60 to 70 kg. Okay, there are very few people with 30 to 40 kg weight. Most of is here. You can now
That's
make your own decisions.
Means y-axis is the count, na, sir. How many people are
No,
there?
count is a y-axis. Sorry, yes, you're right. Y is the count. Okay, and x-axis is the interval.
Yeah.
Yes, you're right. On
This is
y-axis we have the
exactly what
count,
I tried to say.
but you are not able to draw. This is what you were saying, but you are not
I
able to
didn't
draw.
use that
Right?
paint.
You cannot
Yeah.
draw the bar graph directly. You have to first create this table. This table would
Yeah.
be converted into bar graph. Yes, so that's what I said. Okay, that's what I said, that you were also trying to say same thing. And towards the end,
Yeah, I just
I'm
told
also
you that.
trying to say the same thing. So yes, so right, this is how you would represent a numeric data,
Histogram.
which is, okay, continuous data or large numeric data. We're talking about single variable now. They're only talking about single variable.
Single
Okay.
variable.
Yes. So this is how you create. Okay. Now let's go back to our presentation. Marks. Single marks. Same way. Okay. So you will say frequency table and histogram. Okay. Marks, same thing. So when you have continuous data, single continuous data, that's what we do. Now you say gender. How will you represent gender? So imagine, okay, how the data set will look like. Male, comma, male, comma, male, comma, female, comma, female, comma, female, comma, male, comma, female, comma, male, comma, female, comma, female, comma, male, comma, female, comma, male, comma, male, comma, female,
Sir,
comma,
like
female,
in
comma.
reverse, sir.
Huh? What is reverse?
Means in the histogram what we drawn for the weight, no, sir.
No, we cannot draw
Height
histogram.
chart.
Here we
Like
have only two values, right? How can you draw histogram?
no, sir. I'll say. If in the
See,
y-axis,
here, no, hold on. I'm telling you no means understand.
Height chart we can
Wait.
use
Let me tell you. Wait.
categorical data. No?
Category. So here, see, you have male, comma, female, comma, male. So here only two values are repeating multiple times. Correct? You have only two values, male and female. Just that maybe male could be 70 times, female could be 30 times. Or male could be 40 times, male could be 60 times. Isn't it? Right? So here you have to count and keep it. So you can draw a bar graph or pie chart representing the data. Did you get it?
Yeah.
Okay, here you cannot think of XY. XY is useful when you have numbers. XY graph is used only when you have numbers. When you don't have numbers, then you can't draw a graph. Because see, you have done graph, right? In 10th class, we used to take the graph paper to our class. So when you talk about graph, you will have to mark numbers. So histogram also, you see, on y-axis, we marked count 2, 4, 6, 8. On x-axis, we're marking 30, 40, 10, 20. So 0 to 10, 10 to 20, 20 to 30 is blank, 0, nothing. Then 30 to 40, right? That's why I did not start 30 from 0 axis. We gave some space. That is for 0 to 30. 0 to 30, we do not have any value. Nobody has weight between 0 to 30. 30 to 45. So when you talk about x and y axis, you always have numbers. Okay. So similarly, if I have to do something like this, okay, categorical data, see, you can draw more complex graph. Okay. And I'm going to show you the list of graph, maybe if not today, next session, whenever. Tomorrow we'll have next session. So Friday we will not have, guys. Okay. Tomorrow only we'll have, and then we'll see you after a week. Okay, I'll send you some study material. Actually, you both have it. Now we are moving to this data visualization. You have those book, right?
Yeah,
What
data
is called data
visualization
visualization
book.
using Python.
Yeah.
Okay, so first two chapter I have not done it. I want you to read first two chapters. Okay, and you can continue to read third and fourth also, and we'll do it. We'll do that. Okay, thing later, but yes. So now what I'm saying is you can have a bar graph, okay, where you can have 0 to 10 or whatever, and you will say here male, female. Okay, so you will say, okay, female, male. This is how you will mark. And of course, you'll have 0, 50, so 70, whatever, right? You will have this. So this is one way to represent your categorical data. Second way to represent in simple graph, okay, is you have pie chart. Okay, so when you have pie chart, okay, how do you do pie chart? We need to have first center, correct? And then you will have something like right? And you can say this is okay. Try to use consistent same color. Okay, this is what you will say. So now you will write here. You can generally in pie chart we write percentage. Okay, and here in bar graph you write the absolute number. Okay, so here you will say male 45%, okay, or 40%. Female 60%. And here you will say male 50, female 70. So you have 120 data. Did you get it? Now tell me what you are saying, Aviram.
Think so, that like I said that male female in the y-axis. What you said in the frequency table, no, sir, is in the for that.
Because see, male female is not a number, so I can't plot on x-axis. Right?
Now understood. Now understood.
Yeah, right. Now here you see I have only marked number here. I have not marked number here. Right? Now, whether I put M first or F first, no, that doesn't matter. Typically, we should put F first because F comes before M in alphabetical order, right? So you can choose which order you want to follow, right? Sometimes what we do is we'll put it in increasing order. Okay, whatever is less, we'll put first. Whatever is more, we'll put right. So that way, M first and F later. Okay. If you might have 3 values. Okay. Now, okay, we'll talk about when we go there. When we go to course setting, we can talk about it. Okay, so let's go back to our graph here. Okay, so gender, what we said, you can have bar graph or pie chart. Okay, same thing with regions also, right? Course rating. Now you tell me. Sales we have done, right? Line graph. Line graph is the easiest one to draw for sales. Course rating. Course rating you can do since it's a categorical data, you can use bar graph and pie chart. Just that you will have more than 2 bars, right? So when you do the course rating of 1 to 5, you will say 1, 2. But here you have order. So remember, you have to do it in the same order. Right? 1, 2, 3, 4, 5. You cannot change the order. In gender and regions, I have an option to change the order. North, south, east, west. I can put south first, north later. Nobody is going to ask me question. But okay, you can say bar graph, pie chart, or you can use line graph as well in a particular order only. Why I'm saying order is this order is important, because when you read it right, our mind, okay, now see, okay, let's talk about what I'm saying. Are you sleeping, Mona Lisa?
No, sir. I'm so sorry.
That's okay.
Oh, what I did?
Yeah, I think you deleted it
Yeah.
also. Whatever.
Oops.
There was some brown mark that appeared. Okay, doesn't matter. Okay,
Okay.
so look at my screen.
Okay, I'm just like
That's okay. That's okay.
my pen. I'm
Just
just scrolling
that's
my
okay.
pen
Don't
on
worry.
mouse
Don't
pad. Not
worry.
that.
Don't worry. Okay, so we're talking about course rating, right? So you have rating 1. Okay, you should have rating 2 here. Okay, rating 3 here. Rating 4 here. And let's say rating 5 here. Now, what I said is, okay, let me put some interesting, make it some. Okay, we will use dark one for bars. Okay. Now I can say 1, 5, 3, 4, 2. Okay. I can say this also. But what happens? Our mind, will not read the numbers there. See, the reason why we put visualization is we don't want the user to read. Okay. So when you see something like this, it gives you a feeling that the number of rating, okay, is increasing, isn't it? You have less number of 1 and high number of 5. This is what our mind will read. Mind will forget that label. No, 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 there's 1 here and 2. It says, okay, now if you look at this, it said 2 has the highest number of rating. Okay, so maybe your course is bad. But our mind, what happens is always reading from left to right. Our mind always reads from left to right. Okay, even though you write 1, 5, 3, 4, 2, people will read it as 1, 2, 3, 4, 5 only, isn't it?
Yeah.
When I didn't put the number, that's what you thought, right? So that's why what we're saying is, do not, okay, draw anything of your choice. This is called misleading. Okay, misleading means what? You put this way and you'll put small 1. Okay, you write 5, 4,
Yeah.
3, 2, 1. People will, okay, this is still better. But what you will do, just to hide, you will say 1 here, 5 here, and then you will put some number here, 4, 3, 2. Okay, this is called misleading. You want to show the graph is looking good, increasing, 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 but it's correct. It's not exactly increasing. So what I'm saying is, yes, you can draw bar graph, you can draw pie chart, and you can even draw line graph. Okay, how to draw line graph? Same way, the way we did for the sales. You draw a bar, line, here, and you put like this. Okay, and here it should be your rating 1. Okay, now see again, rating 0. This is probably 0, right? So if you do not have rating 0, you should not start from this line. You should start from here. This is rating 1, this is rating 2, this is rating 3, this is rating 4, rating 5, like this. Okay, it has to be in order. This is what I'm trying to say. Has to be in order. It has to be 1, 2, 3, 4, 5 only. Whatever be the bar will increase, decrease depending on the actual data. But representation should happen in that particular order only. So you can draw line graph, you can draw bar